I'm still a faculty member at the Taiwan University, Taiwan Jiao Tong University. There's a lot of Jiao Tong University in China, totally, I think 7 of them, right? So we are one of them. And I'm also deeply involved in OpenFog through Tao's introduction and support. I'm now involved also in IEEE Standard Committee as well. So let me talk a little bit about both about the architecture that we're developing and also how do we push it, that's like Tao has said, into standards. To answer Doug's question probably poorly, what will happen in 200 years, I think I would say what will happen in 20 years. I think from time to time, all the folks in OpenFog, when we were designing the architecture. Oh, okay, sure. We from time to time, we jokingly say that we are building the Skynet. And I think in a sense, we're building a Skynet. I hope that we don't need Terminators to create Terminators to attack us. Consider it that way. This as Tao has said, this architecture, computing, communication, and storage architecture, that permeating all the way from the IoT things all the way to the cloud infrastructure. This permeating thing is providing computing along with connectivity, and then we are deploying AI and we're deploying blockchain distributed ledger onto it, and hand over a lot of our decision making to this infrastructure, because simply we are not fast enough. Human beings are not fast enough in doing the job. For example, in a 5G, if we want to support both high throughput connections as well as low latency connections as high fan-out connections, and want to allocate our bandwidth dynamically, I don't think any mechanical manual algorithm can help us to do that. So we are seeing my feeling, when we are all designing this thing with our colleagues, is that we are really, if we put it into context of the 5G, the IoT, and then this fog and cloud computing, we are deploying one of the biggest infrastructure ever. Not only the biggest information infrastructure, probably one of the biggest infrastructure ever. So this is exciting, and that's the reason why I get involved in this. So let me just use a few slides to talk about what we are doing, and instead of doing all those animation, I would just kind of walk through that, and then allow a lot of time for us to have dialogues. Okay. Put it simply, what is edge and fog computing? It's basically distributed cloud computing. What it means is that we want to put whatever people initially want to put in the cloud, in the data centers, we want to now disperse it and allow it to run in a distributed platform. That distributed platform including things, one of these days will be in your set-top box. Your set-top box now only mainly doing routing packets, but consider if you put several terabytes of memory, putting GPU, NPU, TPU, TensorFlow processor, whatever, into it, it will become a very powerful processor, can process whatever your personal data and analytics would demand. It can be a roadside, curb chassis that used to only control traffic lights, but now it's doing all the connected vehicle intelligent transportation system that Tao has been very familiar with. It can be things in your factory that connects all your factory. Now we can do predictive analytics or doing process monitoring all the way through the supply chain. So what we are trying to do is we're trying to make whatever you want to do in cloud computing in all those platforms. But how do we do that? Basically, the way to do it, according to the, what my colleagues and including Tao has been doing, to build a common, as Tao has alleged, not a proprietary, but a more common and open architecture. What we are building is what we call a bowl. A bowl to contain a soup. Now, what is the soup? The soup is the environment that you use to run in the cloud, the application execution environment, the VM that you created, and then you put your own middleware, your own software stack, and then your own application service on it, depends on whether you're providing PaaS, SaaS, or whatever. So you want to have that unchanged. Whatever you can do in the cloud, you want it to be unchanged, and you can move it over to run it in your fog node or edge node, whatever that fog node or edge node is located. So what does it take? We need a virtualization environment in all those distributed devices. And the virtualization environment, if we do it in the most simple way, it consists of these 3 slabs, you can say. One of them is lying in the, right really, at the very foundation of it is our trusted computing base, a trusted computing platform. We mandated it now, and I think there's a common consensus now in the community. We have to have hardware root of trust. And we have to have trusted hardware as well as secure booting to allow us to create a trusted execution environment that can support the most essential security and trusted computing services that all the other things would use. So the first slab is that part. The second slab is end-to-end security. We want the end-to-end means whatever service or microservice module that you're running in your thing, when they want to communicate, exchange information across this whole continuum to another microservice running in accordance with you to provide a overall application, they can be trusted, they can be secured. And finally, of course, we have to extend whatever that's now currently in the cloud to do the cloud platform management and the cloud service management to become a distributed management structure that manages all these nodes. So they have the distributed node management as well as the distributed service and application management. Of course, in that respect, we are hoping that, at least in the open source space, Kubernetes can be extended in an appropriate manner to at least do some of the tasks that we hope they can do. So this is the concept that this is the bowl that we're building to support whatever originally people are supporting in the data center. And in the OpenFog architecture thing, I really like the architecture, which was actually initiated by Tao and Mengcheng and a few other pioneers. The beauty of it is that it's centered around only one logical or a virtual or physical entity, the concept of fog node, or you can call edge node now. The edge node or fog node exactly implementing this bowl to support this application execution environment. However, this node is designed to communicate horizontally what we call east and westbound, and vertically what we call south and northbound. The south and northbound allow us to go through the continuum, connecting everything from the IoT devices and the mobile devices, we don't forget them, to the fog node, and then through multi-layer of these fog node ultimately to the cloud. We don't want to click the cloud. Our cloud is our ultimate reservoir of information, models, a lot of things. So we want to connect to them, but we want to distribute the computing capability and storage capability all over the continuum. And furthermore, we wanted to be able to connect horizontally to other fog nodes. Currently, I know that most of the applications are just basically doing a star-shaped architecture. Whatever we have in the cloud, we want to stretch it to one or more edge nodes in the edge. But ultimately, you will find that you need, think of it, if you are doing a smart building or a smart city, ultimately you will need multiple of these fog nodes connected together to form a network. And the network will be controlled by a higher-level, higher-tier network, ultimately to the cloud, to control the whole city. So we need that the east and west communication as well to connect all the peer fog nodes together. All these things requires us to do interoperability. This is power problem. This is not, yeah. And that's the gravitation problem. Anyways, all these things require us to do interconnectivity, of course, but so we mandated everything to be IP adapted. Of course, I know we know a lot of the brownfield OT, they use different kind of protocol. We hope that there will be appropriate proxy there and gateway there to do the necessary IP translation. And then there will be interoperability, of course. There will be composability. The whole thing should look like not different pieces of fog node, just like what we have in a data center, the whole thing looks like a whole reservoir of computing and communication resources. And finally, of course, if you want to make the whole thing, this is not in a physically protected data center, but spread all over the place. To be trustworthy, you have to have trust and security. So I think I'm preaching to the cloud, and I'm using a lot of time. So let me just kind of move far forward to give you guys some of the things that we have already done. For example, this is what we draw about the trusted computing platform, and we also suggest that we follow, we don't invent our own standards in many cases. We suggest that people look into the Global Platform Standard for TEE, look at the TCG Trusted Platform Module spec for doing the hardware root of trust. And then we also, of course, look at how people do trusted communication these days, secure communication these days, using basically using HTTP and TLS or COAP and DTLS, and inside it we can run all sorts of web service messaging. And of course, we also, this is all now into the IEEE standard that we just finished adopting, and also married it with the transaction protocol, the service protocol, that's at upper layer. This is definitely not an exhaustive list, but this is a list that proposed by our members. And we already see, there, of course, as Tao has mentioned, there's a lot of proprietary implementation, but EdgeX Foundry, partly supported by VM and VMware and Dell, has already made an open source implementation, the EdgeX implementation, which actually, if you compare them with the architecture, because Jim and the team also work with us closely. They're a member of the architecture working group. They designed the whole architecture itself is very, very similar to the proposed framework architecture. And the amazing thing what they have done is that they show us that they can actually provide most of the things that's in the bowl, and even something around the, around in the bowl, especially the management part, all in microservices, and then being managed by Kubernetes. So we can see that an open source implementation of the whole architecture is possible, and we can grow it. So I'm inviting all of you to, especially in the consumer electronics community, to think about that, as Tom has suggested. One of these days, I think it's not really need, I think less than 10 years, this thing, everything. I'm actually working on BCI, brain computer interface as well. And the first thing that get me involved into fog is that, we need those things to analyze the real-time brain state. We cannot wait until they get to the cloud, and then you lose connectivity and availability, et cetera, et cetera, et cetera. But anyways, let me just then do something that I think Alex or Doug would like me to do, is to tell you a little bit about the standard activity that we have been doing through IEEE SA, the Standard Association. As Tao said, that standard is very important. If we want to make this a really truly dispersive distributed architecture, how can you not have standards? And then that was built into Tao's, I think when they first founded the OpenFog consortium, they already have this built in, is that the technology development would go hand in hand with standard development. So I know their recommendation and their help, and a lot of help from Doug and Russell and Alex and Rob, everyone. We formed the 1934 standard working group. And the formal working group is for computing and networking architecture framework working group. And then we also form a new standard committee to support these and related activities. And that one has an even longer name, IEEE Communication Society Edge for Cloud Communication with IoT and Big Data. Ooh, okay. But you can see that where our scope and our ambition is. Our ambition is really want people to think about the edge and the fog and the cloud, all in a continuum, and think about how these things can be used to support not only IoT, not only big data, but all the future applications. So we defined that, and even at our first call for participation, we already plan to go beyond so-called fog. We say that edge and fog, all these different technology, they ultimately should be regarded as a part of the infrastructure that permeating between this continuum. And we want to hopefully seek for ways to create at least a common high-level architecture. Probably it's difficult for us to go all the way down to the APIs, but we can do it at a high level. The high-level architecture, the functional architectures, and then develop different kind of things to help people to kind of converge together. So let me tell you what we have done. The first thing we have done is that we put our OpenFog reference architecture in a fast track to be adopted, and that was called the, we have the Angola meeting almost exactly a little bit more than a year ago, 14 months ago, and we adopted this standard back in August and approved in September. So back in June, actually, and then published in September. And it actually have a pretty good impact. It almost raised people's attention dramatically. All these social media citing and et cetera, they jump. And then they keep at a higher baseline. So we really hope that people would now think about the common architecture and start a dialogue. The other thing that I want to tell you that is immediately after we created this reference architecture, this was an adoption. We basically moved whatever we have done in OpenFog into IEEE. We immediately started the second project, the 9034.1, which is the nomenclature and taxonomy architecture. Because we see that people in edge computing, even mist computing, okay, and fog computing, we all develop different terms. And the first thing we need to do is make sure that we talk in a common terminology and have a common taxonomy. And this is approved just most recently. Yeah, I think actually, let me see whether I have the date. It actually was being approved, I think, again in September, in a September meeting, October meeting. And then we can formally go ahead. The one thing that we immediately do is that we actually trying to have liaison relationship with other standard working group. Especially we identify that the ISO IEC under the SC 38 and SC 41, the SC 30 is for cloud computing, the SC 41 is for IoT. They are doing a lot of similar work. The first thing is they have identified, they have developed their taxonomy. The IoT taxonomy has just come out in December. And we already, when they're developing it, we're already trying to establish a liaison relationship with them. And also from them, we realized that they are now the two ISO IEC working group are working together to create a new working group on edge computing. And guess what? Their first activity is the vocabulary standard. And we are already working with them. They're already trying to work with us. So what we are trying to do is that we're trying to hope that hold the three working groups together, we can create finally a common set of vocabulary, all the way from the IoT to the edge, to the fog, to the cloud. And from that on, then we would develop what we hopefully the functional architecture to define the functional spec of the whole thing. So we are moving forward. The kickoff already have done, but we have moved it fast track. And this is actually a call for participation. Please join us. We are all IEEE folks. We can all join IEEE SA. And this is the 9034 working group. And I still can serve you guys as the chairman for the coming year. And I hope I would like to work with you guys. We plan to push this, the first draft of at least the vocabulary part, out by our first meeting the first draft in our first online meeting in March. And then we can then have a dialogue with all the other entities and hopefully get a convergence. So I've already talked a lot. I'll just stop here, and then I think Doug would like to lead us into discussion. Thank you.
Whoop.